Hello guys, today is our presentation of the thin section analysis of my study area, the petrography of the MECO section of the carbonate rock. This is my study area of formation. The lower is Dumanda, upper is the MECO formation. So firstly, the thin section which we study is the laminated planktonic foraminifera, organic rich wake to pegstone. So you can see the laminated organic foraminifera, planktonic foraminifera, and have organic rich with the wake to peg means sometimes it's wake and sometimes it's pegstone. So the outer rim is deposition because a lot of laminated planktonic foraminifera and the there is organic rich. There is another view. We can see the layer planktonic forums. We have a mecrite, but in this mecrite we have organic rich mecrite. We have sponge spicules, and later on we discuss what is sponge spicule. Then we have a calcite cementation. Then we have a stalolite. So firstly we will be explain the what is the sponge spicule. Then we explain the calcite cement. Then we'll be explain the stalolite. So the firstly what is sponge spicule? There is one paper that shows that the sponge spicule not always in the deep marine. Sometimes it will be available in the shallow or deltaic kind of setting. So this paper they show like this, but the main reason that they also show that most of the time the sponge spicule in the deep marine environment nowadays. So most of the outer rim they have a sponge spicule. In this paper they also indicate the sponge spicule have this kind of types, and which high energy shores is the lithicide, and hexatinized is the muddy subshores, and demo sponges they have a specular made floor across the sea floor. I mostly reference this fluvial book for my thin section. So sponge spicule you can also see in the fluvial book. This is the a lot of varieties of sponge spicules in this fluvial book. There is another reference from the this book, the Peter Skoll book, in which we can see a lot of sponge spicule here. We have also a sponge spicule reference from the Adam McKenzie textbook. So you can see the from the 101 thin section plate, they have same like thin sponge spicule plate in this Adam McKenzie book. Then we have a stalolite and calcite formation. So you can see stalolite is the zigzag, and the calcite cementation white color, which is the diagenated fabric. So this is the stalolite zigzag. How it forming? It form firstly the pore water, which is which is move or which is already present in the during the deposition. They move along the these fractures, along the fracture of the grains, and they dissolve the grains. So they remain along the this organic rich or matrix rich organic matter when they move along this after deposition, after dissolution. So when they dissolve, so they dissolve in different manner because different grain have different behavior. So that's why they form in the zigzag motion. Then we have a fracture. So after deposition they have a diagenesis. In this diagenesis they have a pressure solution of the fluid which dissolve the rock. After that they forming the stalolite, and then after tectonism they forming the fractures. In this fracture the calcite is coming, and they forming the calcite precipitation. So there is another reference from the calcite precipitation from the fluvial book. You can see the rhodolerian rich wakestone. We have a lot of calcite cementation, a different network of calcite cementation. They have a shear fracture fusionated forms in which they are dislocated because of the stresses. They have also the calcite cementation field. We have the micro crack with offset bioplastic mudstone. We have the Burroughs limestone which is cross-cutted calcite vein. So we have also the calcite vein here. We have this vertical micro cracks, small micro cracks by dewatering of the sediments. So we have like a couplets of the mud layer or the layer of the quartz grain. And in the last we have a bedded is the fenestral veinstone We have also diagenetic calcite vein. So these all are the reference of the calcite vein which will be see in the thin section is the diagenetic fabric. We have also see this in this book, Adam McKenzie. They have also show the calcite vein in the carbonate thin section. We have also this reference of this book 235 thin section. We have a calcite vein in the carbonaceous thin section, image of the carbonate rock. We have also the styrolite reference you can see from this book. We have Adam McKenzie. We have also they reference the styrolite fracture in this thin section. So another microfiches which you can see is the laminated Plantani foraminifera, but they shows the anoxic environment, shows the oceanic anoxia. As we discussed, it's the layer Plantani foraminifera, so they show the outer shelf, outer rim kind of setting. The organic rich rumination, so I take some one paper how they show the organic elimination. So in this paper they discuss about the fracturing. One is conventional reservoir and unconventional. Conventional means directly they pump, already they present in the reservoir rock, but unconventional reservoir they target the source rock. So in this paper they discuss that the most of the source rock, which is the brittle nature or the silica cementation, so they are good for the source rock, but most of the rocks which are carbonate materials, so they are not a good source rock to directly unconventional reservoir. So the organic elimination in the anoxia in my thin section, they are the reference from the this scholar in the this chapter of the Peter book of the carbonate petrography book, and we have a fluvial book also, and we can see in this chapter number in this page 614 they show that organic elimination show anoxic event. There is one other paper which they show that a lot of organic matter is deposited around the MECO interval. So here is also they are related to my study area, and they also show that most of the time the organic matter they are deposited along the MECO event at the marginal shelf, and deep there is no, because we have still oxygenated water, so they are not allowed to build the organic lamina. So they discuss about the hydrological cycle, how it formed the organic matter in the shelf environment. They also compare the PETM versus the another MECO interval, the carbon deposit. So along the PETM, too much organic matter is release, organic carbon release, because it's the huge anoxic event. But here in MECO interval there is not too much organic matter is releases. So now I will start the organic matter elimination or organic matter dissemination relation with my MECO interval or along this climatic change along the MECO interval. So whenever I see the laminated organic matter, so it's like a early MECO stress. Then if you see the disseminated, so is the like a peak of the MECO interval stresses. So firstly the laminated organic matter, which is the normal kind of setting. So oxygen in the renewable to bottom water become little bit now start weakening. After that the lamination is increasing and the organic matter is laminated. Then the disseminated organic matter is increasing. Then we have more disseminated or parts rich crust is coming. Thank you so much.